Hello everyone. So today I will discuss about the graph data structure. Okay, in this series, this is the first video from graph data structure. So today I will just talk about the theory part. Means what is the graph, how to represent a graph, what are the different types of the graph, what are the different traversal techniques of the graph. In the future video, we will cover the questions which are based on the graph data structure. All right. So first question which will come to your mind is, hey, what is a graph? Okay, so graph is nothing but a non-linear data structure that consists of a finite set of vertices, also known as node, and a set of edges connecting them. So here you can see in this diagram, there are four vertices we have, 0, 1, 2, and 3. So these vertices are comes under the node. Okay, we can represent these in the form of V. Okay, V denotes number of nodes or vertices in the graph. Now we have, there is one edge which is connecting 0 and 1. Then there is one more edge which is going from 1 to 2. Similarly from 0 to 3 and 3 to 2. So these four are known as the edge. Okay, so any graph is nothing but will have these two things, number of vertices and how many edge or what are the edge it has. So be very simple. In this example you can say 0, 1, 2, 3 vertices we have. Along with that we have edge like 0 to 1, 0 to 3, 1 to 2, 3 to 2. All right, so this is the simple definition. It is a non-linear data structure that consists of a finite set of vertices and edge set of edge connecting them. And how to represent a graph? We can represent a graph with the help of V and E. G equals to bracket V and E, where V is the number of nodes and E is the number of edge in the graph or set of edge in the graph. I hope it is clear. So next is what are the types of the graph, right? So there are two types of the graph. One is the directed graph and one is the undirected graph. What is the meaning of directed graph? In this graph, edges are connecting using arrow. That is, you can just go in one direction, or in simple terms, we can say these are unidirectional. So here in this example, we are going from 0 to 1. Okay, you cannot go from 1 to 0 back because this is unidirectional. You can go from 0 to 1 only. So these kind of graphs in which we have arrow or in which we can just go in one direction based on the arrow, those graphs comes under the category of directed graphs. Now we have undirected graph as well. So in this graph, edges are connecting using simple line without arrow. You can see there is no arrow. It means that you can go from 0 to 1 and you can also come back from 1 to 0 also. Okay, so these are known as bidirectional graph also. All right, so till now what we have discussed, what is the graph data structure, what are the types of the graph data structure. All right, so please take a screenshot if you want, if you are making some notes and all, and it will be very easy for you to revise in the future. Now, one second. So let me decrease the size here. So how to represent a graph? Next part. Okay, definition is done. Types is also done. Now we got a graph. Now how to represent the graph in the code? Let's say you want to write down the code, how you will represent it. So to represent a graph, I have taken one undirected graph example. Here you can see 1, 2, 3, 4, 5. And these are the edges which are present in these nodes. Okay, so very simple approach is you can just use one 2D matrix of size V cross V, where V is the number of vertices in the graph. Okay, so here how many vertices we have? We have 5 vertices. So what I was saying is you just need to take one 2D matrix whose size will be 5 cross 5. It means 5 will be number of rows, number of columns will also be 5. All right, so this kind of representation in which we use a matrix to represent age between the graph, that is known as the adjacency matrix. Very important, guys. Okay, so How to represent a graph in the form of adjacency matrix, we will understood now. So here in this graph, very simple you need to do. So if there is age between node 1 to node 2, so in this matrix, so for each node, we have one row, okay? And for each column, we have all the node again. So what it means from 1 to 1. So it means that do you have age from node 1 to node 1? Here, no, just mention it as 0. If you have age from 1 to 2, yeah, 1 to 2 we have age. So just update the matrix value as 1. So this matrix will always have two values. One is the 0, one is the 1. So 0 means there is no age between this vertex to this vertex. And 1 means there is age from this vertex to this vertex. So here quickly we can verify. So we can see that we have age from 1 to 2. Yes. So 1 to 2 is 1. Now we have 1 to 5 also. So you can see 1 and you can see 5. So there is an age between 1 and 5 now, right? So this is how you can represent a graph in the form of adjacency matrix. I hope it is clear. Now, what is the problem with this representation? So let's say when number of age are very less than the number of vertices multiplication. Okay, what it means. So in this matrix, how many nodes we have? In this matrix, total 25 nodes we have. 5, 5, 5, 5, 5, right? 25 nodes we have. So if let's say out of 25, let's say very few 1 are there. Okay, it means out of 25, let's say only 3 1 we have. So if we have just 3 1, it means in this matrix, maximum nodes are having the value 0, which is not good. We are wasting the memory, right? So these kind of graphs are known as the sparse graph, and these kind of metrics are known as the sparse metrics, right? So because of this problem, we will improve this particular issue with the help of adjacency list representation. So no worry about that. Let me quickly jump to that. So let me quickly explain you one more example for the directed graph. So in this graph, what we are doing is we are doing the directed graph representation in the form of adjacency matrix. So let me quickly explain one example. So from 1 to 2 we can go, and from 1 to 4 also we can go. So in this row, 1 to 2 should be 1, and 1 to 4 should also be 1. Rest all are 0 because there is no age from 1 to 1, 1 to 3, 1 to 5, 1 to 6. All right. Similarly, we can for the node number 2. From node number 2, we can just go to node number 5. So 2 to 5 should be 1. So matrix of 2 to 5 should be 1. Rest all will be 0. All right. So we are clear now. Now, second way of representing a graph is adjacency list. So in this list, what we do? Okay, first thing you need to take one array whose type will be list and whose size will be same as the number of node or vertices in the graph. All right, we can see here we have 5. Okay, 5 nodes, so array size will also be 5. Now each node will point to a list which denotes to what all node I can go. Okay, for example, from node 1, you can go to node number 2, you can go to node number 5. So this list will have node number 2 and 5. Similarly, from node number 2, you can go to 1, 3, 4, 5. So 1, 3, 4, 5. Here, order doesn't matter. You can insert in any order, that is absolutely fine. Similarly, from the node number 3, you can go to 2 and 4. So 3, 2, and 4. Now, what is the advantage with this approach? Here, we are not storing the 0. Here, we will just store the node which are having the actual age, right? So in the previous example, you will see there are a lot of 0 in this matrix. 0, 0, 0, 0, right? Lot of 0 are there. So unnecessary, we are wasting a lot of memory. So with the help of this representation, we are saving a lot of memory because we are just storing the nodes which are having actual age. Okay, so here if you'll see 1, 2, 3, 4, 5, 6. Okay, total 6 edges are there. Sorry, 7 edges are there. So you will see we store those 7 only. Why we have 14 here? Because of the bidirectional nature. All right, so that is fine. Now let me explain you one more example in which I have represented adjacency list for the directed graph. So from node 1 you can go to 2 and 4. From node 1 you can go to 2 and 4. From node number 2 you can just go to 5. From 2 you can go to 5. From 3 we can go to the 6 and 5, 6 and 5, and fine. In the last we have node number 6. From node number 6 I can go to 6 itself. So this kind of loop is known as the self loop. Please keep in mind this will come in the future videos. Okay, so self loop is nothing but if a node is having the loop on itself, that loop is known as self loop. All right, so quickly I can show you one more example. You can just take the screenshot. It's very simple. If you want to represent in the form of matrix, so from 0 to 1 we have 0 to 1 is 1. From 0 to 3 we have 1, 0 to 3 we have 1, and so on. You can see similarly we can do with the help of list also. So this is all about the graph representation. Till now what we have discussed: what is the graph, what are the types of the graph, how to represent a graph. We have discussed two different approach with the help of adjacency matrix and with the help of adjacency list. All right, second important part is the graph traversal technique. So you are able to draw a graph now, let's say. Okay, now you want to traverse the graph, you want to print the data of the graph. So what you need to do, you need traversal technique by which you can traverse the complete graph, right? So for the graph there are two traversal technique. One is the DFS, depth first search. Second is the BFS, breadth first search. So we will quickly explain you, I will explain you with the help of an example. So in case of DFS, what we are saying, depth first traversal. Okay, so here what we are doing is starting from any node, okay, and keep going until you reach dead end. Okay, once you reach to the dead end, just come back from that node and just try to find another path from the previous nodes. Okay, what I mean is, let me explain you. So let's say you want to start from the node number 0. From node number 0 there are two child it has. So let us pick any one. You pick, let's say 1. So from 0 you will go to 1. From 1 you can go to the 2. From 2 we cannot go anywhere. Okay. So and yeah, one very important thing, when you were going from node number 0 to 2, 1, from 1 to 2, please keep printing the nodes and also mark the node as visited node, so that we will not print the nodes multiple times. Okay, now you will print 0, 1 and 2. All right, now if you will come back from node number 2 to 1, from 1 we cannot find any other path. You will go again to the parent of 1, you will come to 0. From 0 we can go to node number 3 now. So from 0 you can go to node number 3 now. So this is how we have printed 0, 1, 2 and 3. So why we are not printing node number 0 multiple times? Because of the visited value. Okay, if node is already visited, please do not print it again. So this is how the DFS so DFS traversal technique will work. All right. So second is your BFS traversal technique. So in this is very similar to our level order traversal in the tree. So first of all, we'll start from a node. Let's say node 0. Now you will print all the neighbor of the node 0. So 1 and 3. Okay. Then you will print the next all the level, next level all the node. So here we have node number 2. Okay, so 0, 1, 3 and 2. All right, so how it will work? You will start from the node 0, let's say, and first of all visit all the neighbors of the node 0. Once we are done with all the neighbor of the node 0, just pick those neighbors one by one. So now pick one and print all the ins and print all the neighbors of the node 1. Then pick 2, print all the neighbors of the node 2, and so on. That way you will get the BFS of the graph. All right. So next part is very important. What are the application of the graph data structure? Okay. So this is very important because, right, whenever you are learning something, what is the first thing which will come to your mind? Hey, where we will use these things, why we are learning these topics, right? That is the most important thing. If you will see, hey, these we will never use in our life, why we are doing this study then, right? There is no logic sense. But graph data structure is the one which you will find that a lot of companies like Google, Facebook, a lot of other companies will also use these data structure. So where? Okay, first example I can give you is the Google Maps. In the Google Maps, let's say you want to go from point A to point B in a city. So there can be multiple paths. Okay, there can be multiple ways you can go. But the path which will give you the shortest path, Google will try to show you that one. Okay, so how they are calculating those things with the help of graph data structure. In the future video, I will discuss the question which will give shortest path between any two vertices. All right. Next application is in the Facebook. So in the Facebook, what you have? Let's say you are the one. Okay. You have 100 friends, let's say. Now what we will do, you are a node of the graph and all of your friends will form an age with you. Okay. So if you have 100 friends, then there will be 100 ages connected to you. Okay. And just to show the friend suggestions in the Facebook, they will use the graph theory concept. Okay. This is very famous example of the undirected graph. Because why? If you are a friend of someone, that someone is also friend of yours. So this graph is an example of the undirected graph. If you want to check, just search about this API on the developers.facebook.com and you can dig deep about this API. Okay, so if you will learn about the graph, it will really make you fall in love with the graph data structure. Okay, so next one is your Google page ranking algorithm. So in that, what we have is we have how to rank your page. Okay, so whenever you will search something, okay, your website, your blog is coming on the first page, second page, or wherever it is coming. So how it rank your websites? So they will use the graph data structure just to decide those things. So if you want to do research on this, you can do. But if you are completely beginner, please do not worry about those things. First of all, we will understand few simple questions like how to find cycle in a graph and how to print the topological sorting order of a graph. All right. So these how to find shortest path between two nodes. So these simple examples we will discuss. All right. So I hope if you like my content, please like, share, subscribe everyone, and please stay tuned for the future videos.